Hi everyone, I'm Helen and welcome to my video today. I will go through the topic of multiple linear regression, which is built upon the foundation of simple linear regression. In this section, I will cover three main parts, which firstly is the introduction of multiple linear regression. Secondly, it's implementing multiple linear regression in Excel. And finally, I will talk about using Python for multiple linear regression. So firstly, let's go through the introduction. In our previous learning, we have explored simple linear regression, where we try to model the relationship between a dependent variable and a single independent variable. However, in real-world scenario, we often involve more complexity, which we need more than one predictor variable used to explain the response variable. Thus, we measure y as one response using k different predictors x1, x2 to xk. Here is the example of multiple linear regression compared to the simple linear regression. The left image, as you can see, illustrates the simple linear regression where we predict salaries using only weekly working hours. However, in multiple linear regression on the right, we use several independent variables such as the highest educational level, the weekly working hours, and the age of the person to predict one response variable, which is salary. So continue to the multiple linear regression model. It's expressed as this formula with B0 its intercept term, B1, B2 to Bk are partial regression coefficient, and epsilon is the error variance. And this is how the graphical representation of multiple linear regression look like. Unlike simple linear regression, which yields a one-dimensional line, multiple linear regression results in a hyperplane with k dimensions, where k is the number of independent variables. For example, as you can see on the screen, there are two independent variables, which are price and advertising spend, and they are used to predict the sales number. The model is graphically represented as the two-dimensional plane that best fits on the red data point. So first, we have to know the reasons for using multiple linear regression. I would say that it's much better to analyze a predictor after considering the effect of all other predictors. For instance, if you want to understand the impact of a person's weight based on their age, it's better to consider additional factors like height, gender, or so on. Moreover, including more significant predictors in the model can lead to less error variance and improved predictions. So let's compare two scenarios to see the difference between using one predictor and two predictors. As you can see, both models predict blood pressure, but the first model just uses one predictor, which is age, and the sum of ratios or error, which is the difference between the actual values and predicted values, is much larger than the second model. The second one has two predictors, which are age and gender, and you can see it yields better results with smaller residuals and obviously much better compared to the first one. So now let's continue with multiple linear regression equation. In practice, we rarely know the true predictor y due to limited population data. Instead, we use an estimated equation, which is using this formula, and our goal is to find the value of B0, B1 to Bk, so that we could minimize the sum square error value, which is calculated using this formula. So let's continue with the second part, which how to use multiple linear regression in Excel. Here I have a data set of product advertising costs and sales. There are 7 columns which contain information about advertising costs on multiple platforms, with the last column, the product sold, representing the quantity of units sold. I will use a multiple regression model to predict the units sold based on all other costs. So first, let's go to data analysis, and choose regression 1. Click OK. So we want to predict the unit sold based on other costs. So the Y range must be the brush sold column. And for the X range, it will be the other column. I want the output to print here. Click OK. And here it's my regression summary. I want to look closely at some of the following number. Firstly, we have to look at the R-square. It tells us the proportion of the variance in the dependent variable that is predictable from the independent variables in a regression model. And here is how well we are able to explain product sold using the advertising channel. R-square can be from 0 to 1. If the R-square is closer to 1, that means the model better explains all the variance in the target variable. However, if it's closer to 0, that means the model performed poorly. In this case, the R-square value is 0.9999, indicate that 99.99% of the variance in the dependent variable is explained by the independent variables in the model. So that's a really good one. Secondly, we'll have to look at the significant F. This value helps determine whether the regression model as a whole explains a significant amount of variables in the dependent variable relative to a model with no independent variable. My value is smaller than 0.05, which indicates that the regression model provides a significantly better fit to the data than a model with no independent variables. So next we have to look at this p-value of each variable. They are all less than 0.05, which means that these variables have a statistically significant relationship with the dependent variable. And also important one, we have to look at the coefficient column. We can use this number to predict the number of units sold. Like I said before, we have the equation of multiple linear regression is this equation. So for example, if I want to predict the outcome of spending 200 in all channel, so I can use the equation is equal b0 beta 0 plus beta 1 multiple by 200 plus beta 2 multiple by 200, beta 3 multiple by 200, beta 4 multiple by 200 plus beta 5 multiple by 200 and plus beta 6 multiple by 200. So this is the output, and that's all. We can apply multiple linear regression into Excel to predict the outcome. Let's continue with Python. Now I will show you how to use multiple linear regression in Python. The dataset I'm using for Python is a car purchasing dataset, which consists of a list of customers and their gender, age, annual salary, credit card debt, net worth, and their car purchase amount. In this case, my dependent variable, its car purchase amount, is changed based on all other features, so the feature will be my dependent variables. Firstly, I will load the dataset from CSV file using pd.read_csv. Then as I see that there are 3 unnecessary columns, which are customer name, customer email, and country, so I dropped them by using df.drop. And here you can see they're on the datasets when we drop 3 columns. Then I separate the predictors into X and the target variable, which is card purchase amount, into Y. So you can see that their own chaining feature here. The independent variables, and Y's contain the value of card purchase amount. The next step is to split the dataset so that we can keep portion of the dataset for training and the portion of the dataset for the testing. For that, we are going to use chain test split function from the sklearn.model_selection. The test size is 0.3, so it's assigned 30% to the testing set and 70% of the data to the training set, the X chain and Y chain. So we are ready for the machine learning model now. First, I'm import the linear regression from sk.linear model, and I will shape the linear regression model to this variable LR. Continue the line fits the linear regression model to the training data. The model should be trained now, so continue. We can calculate the intercept C and the coefficient M of the linear regression model. As you can see, there are 5 coefficients for our 5 training features below. So the model training is done now. We need to see if the model is actually working. This slide, I try to predict the car purchase amount using training set, and here you can see the prediction. But how good is it? So we have to check using this code. This line create a scatter plot comparing the actual car purchase amount with the predicted car purchase amount, and wow, you can see that here this is absolutely good. Then after this slide, I calculate R² for training sets. As I said before in Excel, R² shows you how close the data have fitted to the regression, and you see that the number is nearly 1, so that's why the model looks so good. So on the above code, I have evaluated the model using the training data, and I also used the training data to train the model. We will know how the model is working actually when we use the testing data, because the model never have seen the testing. So on the code below, I will use the testing data. You can see that we have almost similar kind of visualization. Now the check with R², and it's pretty similar to the below one too. So that's all code for Python, and also the end of my presentation. Thank you for listening.